Explain the generation of low frequency. Explain the generation of low frequency harmonics due to induction generator used in wind power generation. So according to studies, measurements are shown of the harmonic emission of a 30 kilowatt. Okay, 30 kilowatt wind turbine. 30 kilowatt wind turbine they have taken. Okay, wind turbine they have considered together with a capacitor bank. Okay, turbine with capacitor bank they have considered. Okay, example this is. So here 30 kilowatt wind turbine together with a capacitor bank. Current total harmonic distortion, that is PhD, total harmonic distortion is between, that is 5% and 6%. Okay, between 5 and 6%, between 5 and 6% it is current total harmonic distortion. With harmonics 5, 11, 5, 7, 11, 13 being dominant. Okay, so here 5, 11 and 13 being the dominant ones. The current distortion is measured between. So how the current distortion is measured? So current distortion, or you can write, I have written to remember ID. Okay, so ID means current distortion is measured between the grid and the capacitor bank. Okay, and the capacitor bank it is measured, but the main distortion will occur due to the capacitor bank. Okay, once again I say the current distortion is measured between the grid and capacitor bank. Okay, but the main harmonics come from the capacitor bank only. Okay, so the probably due to the main harmonics are probably due to the capacitor bank. The harmonics in the stator current and rotor current of a double fed induction generator. So the harmonics in the stator current and the rotor current. Okay, remember SC and RC, that is stator current and rotor current of a double fed induction generator, as estimated by measurements. The spectrum is shown for frequencies up to 2 kilohertz. The spectrum is shown up to frequencies what? 2 kilohertz. The switching frequency of the converter is sufficiently high, so the resulting harmonics fall outside this frequency range of 2 kilohertz. So here what happens, the switching frequency of the converter is sufficiently high. So what happens, so the resulting harmonics it is more than 2 kilohertz. Here spectrum is shown for frequency only up to 2 kilohertz, but the switching frequency of the converter is sufficiently high, so the resulting harmonics fall outside this frequency range of 2 kilohertz. Here the slot harmonics are present in the stator current. Slot harmonics. Okay, SH is present in SC. Remember like that. Okay, so slot harmonics are present in the stator current due to the finite number of slots in the induction machine, that is, and harmonics 3, 5, 7, 11, 13 and 17 at 0.3 and 0.4% rated current it is. And the measurement you can remember like this. Slots means like this it will be, right? So induction machine, slot harmonics are present in the stator current due to the finite number of slots in the induction machine. Harmonics 3, 5, 7, 11, 3, 5, 7, 11, 13, 17 at rated 3.4, 0.3 and 0.4% rated current. Okay. The measurement shown that for 10% slip, slot harmonics appear at 1030 and 1130 hertz. Okay, 1130 hertz. Slot harmonics appear at 1030 and 1130 hertz. Current source type interharmonics appear in the frequency range of 750 to 1000 Hz due to rotor slots in 4 and 6 pole induction generators rated at tens of kilowatt. So near 10% slip, 10% slip. Measurements show that for 10% slip, slot harmonics at 1030 and 1130 hertz and current source type interharmonics. Okay, interharmonics IH. Okay, SH for 1030 and 1130 hertz. IH, that is interharmonics for 750 or 1000 hertz. Due to what? Due to the rotor slots. Okay, due to the rotor slots in the 4 and 6 pole induction generators rated of tens of kilowatt.